Okay, here's warm up 6.2. If $2,000 is invested at 5% annual interest, how much is it worth after 10 years? Okay, so I'm going to need, since this is annual interest, we're taking the 5% once per year. And so I just need my basic exponential growth formula, which is going to look like this. Okay, A is the principal, the beginning amount of money. Sometimes you'll see that written with a P for principal. So that's the money we're putting in, which is 2,000. So the 2,000 goes here. The finishing amount is Y, which I don't know yet. That's what I'm trying to figure out. Okay, and then my rate is the percentage. So yeah, it's 5%, but we want to write that 5% as a decimal. So that would be 0.05 as a decimal, right? You move the decimal 2 places to the right, or to the left, rather, to change it into a decimal. So I've got 1 plus 0.05, so that would be 1.05. And then the time is 10 years, so 10 is my exponent, okay? Now, next step is to simplify and make sure you do the exponent before the multiplication. So I'm going to use my calculator, but I'm going to do that, and then I'll multiply by 2,000 last. You got to follow PEMDAS, order of operations, right? 1.05 to the 10th is this. So let's see, y is about 2,000 times 1.63, something like that. But I'm going to use that nice long decimal. I'm not rounding as I go, even though I did when I wrote that down. But I'm going to multiply that decimal by 2,000, and here's what we end up with. And I'm going to round to the nearest cent always for money problems unless directed otherwise. So $3,257.79 is what we'd have. Okay? All right, next up. We got $3,000. This time it's compounded quarterly. Okay? So we need a slightly fancier version of this formula. We need one. So here, number of compounds per year was 1, but when we're compounding quarterly, that means we're going to put the 4% in 4 times per year, right? So my n would be 4. So I need a formula that has n's in it, and it's going to look like this. You could actually use this formula on the previous problem. It's just your n's would be 1, and r over 1 is just r, and 1 times t is just t. So it's simplified to that if n is 1. Okay, so don't know the finishing amount, but the starting amount is 3,000. My rate is going to be 0.04. Don't put it in as 4. It's 0.04 as a decimal. And then number of compounds is 4. Okay, I've got another n up in the exponent, so that's 4 again, and the time is 7 years. And there it all is. Okay, and now I'm going to start sorting this out with my calculator. I always start with the fraction, kind of work my way out from there. So 0.04 divided by 4 is 0.01, and then if I added 1 to that, that means we'd have 1.01, and then 4 times 7 is 28. I'll go ahead and simplify that. Okay, so and then I would do the exponent next, so 1.01 to the 28th, and then the last thing is to multiply by 3,000. And that gives me, let's see, $3,963.87. Okay, all right. Next up, we've got annual interest again, so this one, compounding once per year, so that means I can use the formula without the n's. Okay, let's see, estimate how long it would take $100 to triple. So our beginning amount would be $100, and if it's tripling, that means the finishing amount would be $300. So we're seeing how long it's going to take $100 to turn into $300. Okay, my rate's going to be 4%, 0.04, so once I added that, it'd be 1.04 there. And the thing we don't know here is t. We're trying to solve for t. Okay. So we're trying to isolate t. So you could start by dividing by 100. Sorry about the bell there. Okay. And then I'm trying to solve this. Now, if you know how to do logs already, you can put this in log form and get a nice accurate answer. If you don't know about logs, you could do a guess and check kind of thing. So let's go ahead and try to do that. So I'm going to take 1.04 and I'm just guessing. I don't know what the answer is. I'm going to see, well, what would happen 5 years? Okay, it'll only be $1.22. So let's up that a lot. I'm going to want 1.04. Let's try, see what would happen with 20 years. Okay, 2.19. It's getting closer. I'm looking for this to be about 3, right? So 1.04 to, let's try the 30th. Okay, I overshot it because now I'm at 3.24, but now I know it's between 20 and 30 years, so let's try 25 years. I'll try 1.04 to the 25th. Okay, so more than 25, less than 30, and I'm narrowing in on it here. I'm going to try 27th, a little closer. Try 28th. Okay, now we're really close, right? So I'm going to say about 28 years then, because if I go to 29, I think I'll overshoot it by quite a bit. Let's test. Yeah, so it looks like it's closer to 28 than it is to 29 there. So I'm going to say about 28 years. Okay. All right, that's it for this warm-up, and I'll see you next time.